Hi class, this is Nagamani Gorte. Today I am explaining about real world problems on vertex form of parabola. Then this lesson was taught in my class 2 weeks back. How to derive vertex form using graph and algebraically. So before teaching this lesson, they should have prerequisite skills that they should know about factoring quadratic equation in completing the square form as well as algebraically they should know. Students are required to have certain knowledge of graphs and vertices. Objectives used to the students are to graph quadratic function in vertex form, to convert quadratic equation from standard form to vertex form, to convert quadratic equation from vertex form to standard form, to write a quadratic equation for the graph of parabola. Through this lecture, I try to introduce the fundamentals and enforce them with multiple examples and working samples. I'll begin the lesson with explanation of task, graphing quadratic functions in the vertex form. This lesson actually connects with the previous experience and knowledge of quadratic functions in a new way of writing quadratic equations. Student will understand what the parameters a, h, and k do with the graph of a parabola. So they will write in the vertex form of parabola and they'll sketch the graph of parabola with given equation and write the equation based on real world problems using the vertex form. So they in this task they need to answer these essential questions. How can we determine if a real world situation should be represented by a quadratic, polynomial, or exponential function? How do quadratic equations and their graphs or tables help us interpret events that occur in world around us? I provide the perfect analogy to exemplify the graph of parabola using basketball example, and I will ask the students to answer these questions. Is he going to make it? Can you draw me the path of shot that will make it? That will is that miss it? After seeing the real world situation, students visualize and draw scratch diagram of path of parabola and they will try to identify and locate maximum point of the parabola and also they will try to locate the time in how many seconds it reached the ball reached to the maximum height they will try to identify. After the real world application on parabola, students were given a task that is the function y equals to negative 5 times x plus 3 whole square plus 4. They have to find out the vertex and axis of symmetry. Students are able to draw the table and they were given at least 5 values of x. So they derive 5 values of y, and they will start the plotting the points on the graph. So they will draw the parabola, and after finding the parabola, they will see the vertex, that is the minimum least point in the parabola. They will identify. So they find the vertex, and through which line the parabola is symmetry also they will identify. That is called axis of symmetry. The least point of parabola is vertex, and through which line the parabola is symmetric is called axis of symmetry. They will identify both vertex and axis of symmetry. I will give task to the students, that is a quadratic equation y equals to 2x square minus 8x plus 6, and I will provide for each and every student graph sheet so that they draw the graph on the graph sheet, and they will prove graphically as well as they will prove algebraically, because they are having a prior knowledge of completing the square. So first they will find out from the graph, and then afterwards they will justify their answer using algebraically. By drawing the graph, students located the vertex and axis of symmetry. The vertex is the lowest or highest point of parabola, and the axis of symmetry is the vertical line through the vertex of the parabola. By graphing the parabola, students will observe minimum point as well as through which line the parabola is symmetry. So that is called a line of symmetry, and the minimum point is called the least point is called vertex in the parabola. So that is y equals to a times x minus h whole square plus k. If a is positive, parabola open upwards. If a is negative, parabola open downwards. The vertex is the point of h and k. Algebraically, we can say a times x minus h whole square plus k is called vertex form. Axis of symmetry is the vertical line, that is x equals to h. By graphing, students identify the vertex and axis of symmetry. Now they will start by using graphically. They will justify their answer by using graphically. Students have prerequisite skills of completing the square. Using completing the square, they will start doing quadratic equation in the form of a times x minus h whole square plus k, where h and k is vertex of the parabola. I have given another problem for continuation of the task, that is y equals to x plus 2 whole square plus 1. So I will ask the students, to find vertex, axis of symmetry, and what are the properties of the graph looks like. Suppose after finding the vertex, students will come to know that is the minimum because the parabola is open upwards, and they will also conclude that if the parabola open downwards, the vertex is the maximum, and the axis of symmetry is vertex near vertex. What is the value of x is called their axis of symmetry. So they are able to identify vertex, axis of symmetry, and also nature of the. Another example was given to the students to analyze the graph, and they'll find the vertex as well as the axis of symmetry. So not only using graphically, they will solve using algebraically. That is, already it is given x plus 4 whole square minus 3. Students will identify where h is negative 4 and k is negative 3. That means it moves left side 4 units and down 3 units. That means it is showing horizontal translation as well as vertical translation. So, because they are having a prerequisite skill of transformations, they will identify from the graph as well as from the equation. Cognitive demands of this task is focus students' attention on the use of procedures for the purpose of developing deeper understanding of mathematical concepts. That is, completing the square, we are developing into deeper understanding of vertex form. The vertex form is useful in the real world situation. With the example we have seen, that is basketball, then how far it reached in within the time limit we can find out using the vertex form. Vertex form usually are represented in multiple ways, that is visual, diagrammatic, and manipulative. Visual we are seeing it graphically, and diagrammatic we are observing real world situation, and also we are using algebraically. Require students to explore and understand the nature of mathematical concepts, processes, or relationships. Students were given a practice problem, and they will identify whether parabola open upwards or downwards, and vertex as well as axis of symmetry. Then they will find a table of values with 4 points other than the vertex. So students will identify open upwards or downwards means they should see the value of A. If A is positive, then the parabola open upwards and the vertex is minimum. If A is negative, the parabola open downwards and the point vertex is maximum. So they will identify H and K as well as A. So using those three, they will identify parabola open upwards or downwards, and the maximum point and minimum point, the vertex and axis of symmetry. Overall, the class was very active and engaging while doing the parabola and the graph of the parabola. The interactive solving session we had as a class over the problems, helped a lot of students and allowed them to get the idea about the topic. The students had a set of problems to work on as homework to solidify the learning even more.